All right, good morning, everyone. Thank you for joining me today. How are you all doing? All right. It's a nice thing about being at the start of the conference, right? Everyone's all gung-ho and ready to go. So I'm Kristin Marsicano. I am here to talk to you today about one of my favorite topics in Android, which is the activity lifecycle. So I first want to do a little expectation setting. I have set up this presentation for beginners, but my hope is that even if you're not a beginner, that you can still get something out of this. At the very least, hopefully it's a semi-entertaining review of a very important topic. And also I'm expecting a little bit of audience participation. It's not going to be much, but if you need to go get your coffee, you can go do that now. So I want to start with a motivating example. So I've written this app called Ticker Tally, right? I'm working at the bar and I'm the bouncer. And I'm counting how many people are coming in, right? So rather than having this mechanical device, I've written an Android app to do it on my phone, right? So I am, counting people as they're coming in, la 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 la. All is great and well until, dun dun dun, I rotate my device. Okay, now I've only counted 7 people. I probably wouldn't be too upset, but if I've been doing this all night and I haven't kept track in my mind of the number, I have lost my information, and as a user, I'm going to be really upset. So, my goal for today is to empower you to reason about the activity lifecycle so you can avoid common problems related to lifecycle like state loss on rotation, so that you can reason about how you want to structure your activity code, but most importantly, so that you can provide a smooth experience for your user. All right, so let's step back for a minute and talk about what the heck is this activity lifecycle that I keep referencing. So we'll start with an activity, right? An activity, roughly speaking, represents a single screen that your user is interacting with. As a developer, you probably know, even if you've only just done a Hello World tutorial, this means you're writing some Java class that's extending from some framework activity class. Right here, I've got ticker activity. And in my ticker activity, notice I have this instance variable, mCount, at the very top. And I'm setting it to 0. So whenever I create a new ticker activity, I am initializing my count to 0. And then I've got some other stuff going on. I've got this onCreate method, which you may or may not have seen, and I'm doing some setup with my UI. But that's my ticker activity. And what's not shown here is ultimately when the user is pressing the button, I'm incrementing the value of that mCount. All right, so that variable becomes very important throughout this presentation. So here's the thing about activities, right? You write all this code and that's great, but you will never create an instance of your activity, right? You will never say like, hey, new activity A equals new activity. Instead, you rely on the operating system to create instances of your activity at runtime based on what your user's doing. And they do it, the operating system does it in response to something called an intent. So here's a simple example. The user clicks on the ticker icon on the launch screen. This issues a request, an intent, to start my ticker activity. There's something that lives in the operating system called an activity manager, which is listening for these requests, and so it's going to spin up a process for my application to live in, for my activities to live in. It's going to create an instance of ticker activity, all right, and then it's going to move my ticker activity to what we call the running state. So now the user sees my ticker app, and they can interact with it. Step back and looking really quick at this whole process thing. Really what matters for this talk is that every application on your device gets its own process that it runs in. And for us, really what we care about is that's where your activity instances will live. It's that little piece of memory that's used to store your activity instances. So when our ticker activity was launched, right, we got a process for our application, ticker activity instance was created, and then it was moved to the running state so the user can interact with it. A key rule about activities: only one can ever be running in the foreground at a time. Only one can ever be running in the foreground at a time. So I keep talking about these states. All right, so let's talk for a minute. What are the states that are part of this activity lifecycle? I think of them as 4 main ones. There's 3 outlined in the documentation, but ultimately we have non-existent, we have stopped, we have paused, and we have running. And what's important about these states is to understand, well, what does that mean that it's stopped or it's non-existent, right? There's 3 key things to know about each state. So, do I have an instance of my activity in memory? right? So that matters for things like when I have a count variable that I'm relying on being there, is there an activity instance alive that's holding that information for me? Is my activity visible to the user? Can they see my activity? And then finally, is my activity in the foreground? Is it that one activity that that has user focus that they're actively interacting with? And we'll go through these in more detail throughout this presentation, but a quick overview here. Non-existent. This is where your activity is not created at all. It's not in memory, and obviously the user can't see it. Stopped. Stopped is where, okay, there's actually an instance of your activity in memory, so any instance variables you've set up in there are accessible. They're there and alive. But it's not visible to the user. Paused means that, okay, there's an instance in memory, and now the user can actually see your activity. And in some cases, they can only partially see it. But it's not in the foreground. It doesn't have user focus. It's not what they're interacting with. And then finally, running. Okay, also this is called resumed if you check out the documentation. Resumed activity, it's in memory, it's running, and it is in the foreground. All right, so this is where your activity is shining and the user is, counting the number of people walking past them. All right, here's the thing about activities. They are super fundamental. They're so important. Like to your user, your application is an activity, right? But you have very little control at runtime what state your activity is in. Right? Instead, it depends on what the user is doing, and also in part what's going on in the rest of the operating system. All right? The thing is, while we don't have control about what state we're in, this life cycle is composed of a set of rules about how the state changes based on what's going on with the user in the system, and more importantly, a set of callbacks that you can hook into. So these callbacks are really just methods that the operating system is going to call on your activity as your activity is moved through these states. You're being notified, hey, the state is changing. All right, I think that the activity lifecycle is best understood by example. And so I want you to take a journey through me, and let's pretend we are the ticker activity. All right, so we're going to step through 5 examples, and I'm going to show you how the activity moves between these states based on what the user. All right. The first example is super simple. We're just going to launch the activity, and we've already sort of talked about this. So the user clicks on our icon, and the ticker activity is launched. All right. For this, you're going to see this same sort of format of slides over and over, so I just want to make sure you sort of understand where I'm trying to go and what I'm trying to represent. So this little box that says Android OS, this is where I'm going to show you what's going on, like from a process perspective, what processes are alive and what activities are showing. This is simplified because at any given time you've got a lot of processes running on your Android device. All right, but we're going to try to really focus on ticker activity in the ticker app. Then on your right side, I've got a screenshot of what the user is actually seeing at this point in time. All right, and then at the top, I'm going to build across a state diagram that shows you what's going on in terms of state for that ticker activity. So we start out in non-existent state, right? There's no instance in memory, right? There's nothing in that little Android OS box. And the user obviously doesn't see your activity. It's not even alive. So the user presses your icon, and the operating system creates an instance of our activity and calls on create, which moves us into the stop state, right? Notice the user does not see your activity yet. Then on start is called immediately following this. It moves you to pause state. So now the user can see your UI, but it's not in the foreground. And then finally on resume is called to move you to running state, which now means the user sees your activity and it's ready for the user to interact with it. Okay, so now let's talk about pressing back. All right, I often call this like the teardown cycle. So the user is going to increment their count to 1. All right, so now notice that mCount variable has a 1 in it, and that is what's reflected in my UI. So the user presses back, and it's going to move us state by state to non-existent. So it'll call on pause to move us to pause state. So now your activity is visible but not in the foreground. Calls on stop to move us to the stopped state. So now your activity is not visible, but the instance is still there in memory. And then finally it calls on destroy, right? The instance is destroyed and the user obviously no longer sees it anymore. So I have a question for you. So we've launched our ticker, we've pressed 1, and now I have pressed back. And I launch the app again. What is the user going to see? Are they going to see, my count that I had counted up to, in this case 1, or are they going to see my initialized count of 0? Who thinks it's going to be 0? Who thinks it's going to be 1? All right, it's going to be 0. Okay, so the key here, if you got it wrong, no big deal, right? That's why we're walking through all of these. The key here is that your activity instance was destroyed. That M count got destroyed along with it. There is no notion of that state anymore, so it has to recreate your activity from scratch. Okay, so this is what the life cycle would look like, right? We were in the non-existent state, and it moved us through on create, on start, on resume to running, right? And created a new instance of our activity with a count of 0. All right, so let's try a similar example. I'm curious, how many of you use Android as your personal device? Okay, notice I didn't raise my hand, so don't feel bad if you didn't. I switch a lot. So anyway, when the user presses home, it's different than pressing back, right? When you press home as an Android user, you're saying, I'm not done with this activity. I may come back to it. I'm switching tasks, essentially, right? And so the operating system is not going to fully destroy your activity. Instead, it's going to hold on to that instance and any state you've stashed in it. Okay, so I increment my count twice. There we go, my count is 2. I press home. All right, what happens is my ticker activity is running. I've got a count of 2. All right, so stick with me here, we're going on another journey. So I press home, it calls on pause and moves me to the pause state, and I can still see it, right? But it's not in the foreground. I can still see my activity on the screen. I press it moves me immediately to calls on stop to move me to the stopped state. So now the user cannot see my activity, but the instance is still alive, right? So what's nice about this is then I can go do other things, right? I can, maybe edit a contact or send an email or look at Twitter, and this process is hanging around with my activity in it, right? So when I'm in this state, right? I've pressed home, and I go do other stuff, and then I decide to relaunch my app from this current state. What is the user going to see? Am I going to see my initialized state of 0, or am I going to see whatever work I've done? In this case, I've counted up to 2. Who thinks 0? I'll play along. Who thinks 2? Okay, so 2 is the answer, right? You can see it here now, and when it's visually represented, it's pretty clear, right? We have this activity instance, and really what's just happening now is it's getting moved from stopped, the not visible state, to running. So now it's in the foreground, and the user, it's visible, it's in the foreground, the user can interact with it. Okay, another one. This might feel a little repetitive, but I promise you it's good practice. It's like going for a jog. So launching another activity, right? This is an example where I am going to press my ticker, I'm going to press the ticker icon and launch now terrific ticker, because now I can save my counts, all right? So I increment my count 3 times, and then I click save. This is going to launch a new activity within my application, all right? And this activity will allow me to enter a file name and save. All right, so let's talk about what happens here. So the user starts off, we're in our running state. Again, we're looking, the state diagram represents what ticker activity is doing. All right, so we are running. The user presses save count. So what'll happen now is a save activity gets created. And the save activity gets run through its life cycle. So it is running in the foreground, right? And what did I say one of the most important rules about activities is? Yes, only one activity can be running in the foreground at a time. So something must happen to the state of our, something must happen to the state of our ticker activity. And what will happen is it gets moved from running to stopped. Now if you think about it, I said stopped means your activity instance is alive in memory, but the user cannot see it. Right? So in this scenario, the user sees that top screenshot. They just see your save activity. They don't see ticker. So ticker moves from running through on pause, through on stop to stopped. Now, in this case, the user now is going to press back on our save activity. Save activity is going to get destroyed. Okay? And so our ticker activity is going to come to the foreground. So it's going to move from stopped state into pause state through on start. And now notice the ticker activity can be seen, right? And when we call on resume, it moves to running, and now it can be actively interacted with. Okay, one more. All right, so this is a very similar example, but now I've upgraded my save activity. Because for some reason I think it's really important when you click save to have context about what you're saving. So I've made, I'm not obviously a UI designer, but this is a good example of the life cycle. So now you can see the ticker activity behind this semi-transparent save activity. All right, so think to yourself for a minute, all right, what state might ticker activity be in? All right, and we'll go through our journey here. So ticker activity is in running state, and we click save count. So it's going to launch the save activity running in the foreground, which we know that means that's going to kick our ticker activity out of running state. All right, so what'll happen is it will call on pause and move our activity to the paused state, and that's it. All right, so it's paused because it's not in the foreground, but you can see it. You can't see it fully, right, but you can partially see your activity. Now the user presses back, save activity goes away, and our ticker activity has less steps to get back to running. Right now, only on resume is called. So what I'm trying to demonstrate here is that it's not so simple as you're always building entirely up and building entirely down, right? It's very possible that you may oscillate between, for instance, paused and running many times, and stopped to pause to running many times throughout the life of your activity as the user interacts with it. So let's summarize for a moment what is going on with this life cycle overall. And I like to think of it as like 3 key sub-life cycles. All right, so here's our entire life cycle, but there's this notion of the entire lifetime, or is an instance of my activity alive in memory? And that really happens between on create and on destroy and everywhere in between, right? An instance of your activity is living in memory. Then there's the notion of the visible lifetime. Can the user see my activity? And this happens between on start and on stop and everywhere in between. So the user can see the screen, but might not necessarily have it in the foreground. And then finally, there's the foreground lifetime, which you can see looks shorter, right? So this is between on resume and on pause. It represents the running state, and this is where your activity is the shining star of the moment, and it has your user's full attention. Okay, so now I want to revisit one of our life cycle walks, which was going home, and this is now a cautionary tale. So we've learned about the life cycle. This is great. We understand like sort of what they mean, the states mean. And we've got our app, and we've done lots of work. Maybe I've incremented to 42 or 42,000 or whatever. And I press the home button, right? When I press home, that's, again, I'm saying as a user, I'm not done here. I might come back. So, I'm expecting when I come back to your app that I'm going to see my count of 42. All right, I press home, and I launch Pokemon Go. I'm sure you're going to see this theme a lot during this conference. So I'm going to play Pokemon Go. This is awesome. This is great. It's slow here at the bar. Not many people are walking by, so I'm going to keep myself busy. Then someone shows up, and I need to go back to my ticker and count, right? So I go back to ticker. Oh, no. So, yes, that's a 0. I was at 42, I pressed home, so I'm expecting 42, but I see 0. So what the heck happened? Let's talk about it. So user, our current state, this is representing right now, is that the user is on our ticker activity. Here I've incremented my count to 3, and I'm in the running state. I press home, which moves me to my stop state. And then I go do something like play Pokemon Go. So now a process gets spun up, as you see in this Android OS box over here, for Pokemon Go. And there's some activity, or who knows what they're called, what's going on in Pokemon Go. We don't really care. But ultimately, life is going fine. But then the system says, uh-oh, this Pokemon Go takes up a lot of resources. I need a lot of memory for people to play this game. And it says, all right, well, let me figure out what things can I get rid of. So it's going to look at your process and say, oh, well, they're not really actively interacting with this ticker activity in this ticker process. I'm just going to get rid of it. So it is going to get rid of your process along with, I'll do that again, any activities, right, any state you have in those activities, all that gets destroyed. Also of note, onDestroy is not going to get called. So it is going to hop you from stopped, you're going to be non-existent, and onDestroy never gets called. All right, oh my gosh. So what is a woeful Android developer to do? All right, lucky for us, there's a mechanism to deal with these sorts of situations called saved instance state. There's an on-saved instance state callback method that the operating system will call on your behalf to stash state from your activity. So the method itself looks like this. We have on-saved instance state. I put a little box around it. That's what I'm looking at right now. There's an input, right, bundle. This bundle is really just like a mapping of keys to values. So I'm going to, in that line right before the bottom curly brace in that box, I have outstate.putInt. So I'm putting my count and stashing it in this bundle of state. So now if we look back at onCreate, onCreate actually has an input that accepts a bundle. So if onSaved instance state is called, whatever you stash will be passed back into onCreate when the activity is recreated. And so as a developer, you should be saving your they call it the transient state. So any UI related state that the user would expect to be there if they hadn't explicitly dismissed the activity, right? So you should be checking, do I have saved instance state? And if so, pull it out and set up your UI accordingly. All right, it looks something like this. So I've got instance A of my activity, right, living in memory, and the user presses home. So my activity is moved to onStop, and actually onSaved instance state is called on my behalf. Because the activity is no longer in the foreground, but as a user, I expect that that activity is not going to die. My work should still be there. I'm not done yet, right? I did not push back. So onSaved instance state gets called, which will ultimately write something called an activity record. So this is living in the operating system outside of the life of my app or my activity, and I can stash information about how I want to, that I can use to recreate the state of my activity, if that makes sense. So here I'm just writing ticker count. So now I go and play Pokemon Go, right? And my ticker activity process gets killed while I'm playing Pokemon Go. But it's okay, because I have an activity record that represents the state that the user was in. So now when I relaunch my ticker app, ticker activity, it's onCreate is going to receive a bundle with my ticker count sent back in. So then I can update that view accordingly. So this is a recreated instance in memory of A. It's really a whole new object altogether that was created for me, but I was able to use information to make it look to the user that it was never destroyed. Okay, so let's take this full circle here. This slide has lots of meanings about full circle. But ultimately, we started out with an example, right, where I rotated my device and my state got lost. That stinks, right? Well, that's because the operating system, when you rotate, it treats this as what we call a runtime configuration. Whenever there's a runtime configuration, Android wants to do its best to recreate things to look best in this new configuration. The most common configuration you could ever think of is rotation, right? So landscape and portrait are different runtime configurations. So the operating system will fully destroy your activity. It will run it through the entire teardown life cycle, and then it will run it through the entire build-up life cycle. So it will create a whole new activity. So if you are using onSaved instance state, it will use this same mechanism just like it did when your process is destroyed. OnSaved instance state is going to get called, like I said, whenever the user is not the one dismissing your activity is a good, simple way to think of it. So if I press back, do you think save instance state is going to get called? No, because back is really the user's mechanism for saying, I'm done, right? But in most other cases, like pressing home, switching tasks, it is going to, and rotation, it's going to call OnSaved instance state for you. Okay, so let's talk about structuring your activity. So for me, I am a very detail-oriented person. For my coworkers here, I'm sure they're laughing inside when I say that. So I'm a detail-oriented person, and I want like a formula for everything. I want to have like concrete examples. I want to know like every single possible combination. And yes, like in onCreate you must do this, and on Start you must do that. In reality, it's not that simple, right? There are some guidelines and there's definitely things people do in practice, right? So on create, you're almost always going to set content view to some, XML layout resource. You're going to do what I call hookup UI widgets. So you're going to, get references to buttons and set on-click listeners and things like that. And you should be checking for save state if that's relevant for your app, if your user has a state that they're expecting to still be there. On pause. Often this is a place people will tell you need to save your vital data, right? It represents your app going out of the foreground. And so if there's things that are really important that your user cares about that you need to persist, not in memory, like on disk or to web or whatever, then you may want to consider on pause. You might also want to think about stopping things that are consuming resources. So we're going to talk about location, video, anything that's taking up memory or CPU. You may want to consider stopping those things because when your activity is going out of foreground, it might not make sense for you to still be consuming them. It might not make sense to still be, polling for location. And things you do in on pause and really in any lifecycle method should be quick, right? Because they are all running on what we call our main UI thread, which is a whole nother talk. But it should be quick because mostly also with on pause, any other activity that might be launching over this one cannot even resume until this returns. Okay, so on stop is actually now our last guaranteed teardown method, right? So you saw that example where the process got killed and on destroy was not called. So on stop really is your last guaranteed callback. So depending upon the requirements of what you're doing, maybe this might be the right spot to persist vital data. And on destroy, I think of that as a place like your last place to free up resources. So like if you've got some background thread you've spun up in on create and you're like queuing requests to do something, well, in on destroy you would want to release that, right? So you don't have to worry about any memory leaks or things hanging around when they shouldn't be. But even though this is not guaranteed to be called, if you think about that example of like a background thread living in your process, if on destroy is not called, your process got killed. So did everything else in it. All right. But really, my point is, it depends. So reasoning about what to put in the lifecycle methods really is like a marriage of your understanding of the states and what they mean to the user and what they mean, in terms of your instance being in memory, and along with what the requirements of your application are with respect to what the user is doing. And so I wanted to go through some concrete examples, I like those obviously, about reasoning about the activity lifecycle and the callbacks and what do you do. So let's talk about displaying location. I've got an app and I want to show the user their location, right? I want to minimize, of course, the amount of battery power I'm using because now there's that screen of shame where people can see how your app is performing with respect to consuming battery. But I want to maximize precision, right? I want to give my user the best experience. I want to have the location ready, and I want it to be really, really accurate. So I might think about some things like this. I've got the callback or the lifecycle diagram here just sort of as a point of reference. But I might want to do something like this. When my activity is started, right, I might want to start sampling, right? I have on create, but when I'm in the stop state, can my user see my screen at all? No. So if they can't see my screen, I might not care about sampling for location data, so I'll start sampling on start, and then I will stop sampling, the very bottom bullet there, in on stop. One thing also in practice you sort of learn is that you should be mirroring build up and tear down of thing. If you're registering a listener and then unregistering it, you should be doing it in the corresponding lifecycle method, right? So on start corresponds, you can see in the diagram, with on stop, on resume with on pause, and on create with on destroy. So anyway, then when the user is moved to the paused state, to the running state, which means that my activity is actually in the foreground, they're actively interacting with it, I might choose to rather than just do my normal, run-of-the-mill sampling, I'm going to increase the sampling rate. So I'm reading location faster, and I'm going to increase the accuracy. This takes more resources, but it gives my user a better experience. So you can use these life cycles to sort of, the life cycle to tap into things like this, right? My user's looking at the app, I want it to be super accurate, I don't care how much better I'm using. But when I step back and it's partially visible, that might be another scenario, right? Maybe you want to downgrade your accuracy and your sampling rate a little bit. Okay, so that's location. So here's another example, video playback. This is near and dear to my heart because I've worked on an app that had a lot of video playback. So one would think when, on pause is called, I'd want to pause my video, right? Not necessarily. You all know better now, right? Because you've sat through this talk. So let's say my requirements are that when my user is watching the video, they can actually launch another activity. It's a full screen activity, but it's transparent. And they can tweak things about the subtitle settings and who knows what else. Well, since my settings activity, it's in the foreground, but it's transparent, what does that mean for my video activity? It's paused, right? So if I'm stopping playback on pause, but I'm expecting the video to play in pause, when the activity is paused, that's not going to work, right? So instead, you would probably want to do something like start playback, not like, you would want to, right? Start your playback in on start, perhaps, well, maybe you wouldn't start on start, we'll go back to that. But ultimately, you don't want to stop or pause playback until the activity is no longer visible, which represents the stop state. All right, and then there's other things like resources. With video players, a lot of times you have to initialize things and tear them down, and so on create and on destroy would be a good opportunity to do that. Okay, so we're nearing the end here, and I wanted to have one capstone challenge, and I actually think this is pretty timely. I'm going to ask you what state, I want you to reflect, you don't have to like yell it out loud or anything. What state do you think these activities are in? Multi-window, right? So I've got two activities here now, all right? I've got on the right this maps activity that I'm actively interacting with. And on the left, I've got Chrome where I'm viewing information about perhaps a location that I'm looking for. All right, so what I want to know, I'm actively interacting with the maps, but I can still see Chrome. Which state do you think the maps activity is in? Think for a minute. Running, yes, okay. Now, what state do you think the Chrome activity is in? It's paused, exactly, right? And you knew this, I didn't have to tell you, because you know now that when something is paused, the user can see it, right? If not wholly, then partially, but it's not in the foreground. And we know that only one activity can be running in the foreground in time, all right? So my point here with this life cycle, the activity life cycle, is that when you understand how it relates to what their user's doing and what it means to the system, then you start to do things, with a reason behind them. And so when new big changes like this come along, it's more than likely that your application is going to behave appropriately. All right, so next steps here, I highly recommend, I love reading the Android documentation. People make fun of me because I read it so much. But if you're really if you're interested in Android developing at all and you're a beginner, please go and look at the online documentation. Engage in local communities. Don't be afraid to ask questions. A lot of things in Android can be tricky when you're first starting, but with a little guidance and a lot of gumption, you can definitely figure it out. All right, so this is how you can reach me. I'm on Twitter at Kristin Mars, and pretty much everywhere, Kristin Mars. I didn't say this in the beginning, but I work at Big Nerd Ranch. We teach week-long Android boot camp, so if you want to come spend a week and learn Android with me, you're welcome to. But I'm not sure how much time I have left, but I'm happy to take any questions or comments. Good question. So what happens when you press the device lock button? Well, let me ask you this, because I've been using not an Android phone for a little bit of time now. When you lock, what do you see on the screen? You see the lock screen. You see the lock screen, but you wouldn't see my ticker, right? So then I would reason that the ticker activity would move to, let's see, it's not visible, but it's probably still in memory, so it would move to the stop state. Yep. And I would also reason that it probably on saved instance state would get called, right? Because the user didn't push back. They're not really done yet. Other questions? Yeah. So, okay, so the question, I'm repeating the question just because people can't hear you. So if So I said that onDestroy actually is not guaranteed to be called, right? We walked through that example with Pokemon Go and our process getting killed. So I said that you should, consider doing like final cleanup and onDestroy, but that might not get called. Is that a problem? So here's the way I think of it: is that number one, if you're going to register something in on start or on resume, then you should unregister it in the corresponding lifecycle method, so on stop or on pause. But ultimately, like if you're releasing, a thread, killing a thread or something that you spun up in your process will get killed in that situation, right? In the Pokemon Go situation where our process got killed, anything you had set up in there is going to get killed. So any references to like objects you had in your process that were referencing things, like those are getting killed. Well, on-save state is separate. Yeah, in on-save state, so when I think about on-save instance state, you should be using that for UI state, right? So if you've got like a whole bunch of, your app depends on data. You would probably have a database locally and that you're caching stuff and you're pushing to the web. Save and instance state is really for that like transient state, and it's really meant for that scenario where, hey, we know as Android developers, the operating system is going to destroy our process and our activity, even when the user thinks they still have that activity around. Yes, if you started like a thread after onCreate, then you would definitely want to tear it down in the corresponding lifecycle. Yep, method. You can write, let's see if I remember this correctly, serializable. Bill, do you remember? Serializable, and the word that I really dislike to say in front of people, parcelable. You know what I mean. So yeah, you can write more than just an integer. Okay, so you're saying, so in your experience, so the documentation says one thing, but your experience is another thing. Okay, so number one, as someone who pores over documentation, I totally feel you, because that happens to me. And actually, as I was, rereading everything before this talk, I'm like, well, wait a minute, that's not. But the specific example was the documentation says on activity result should be called before on resume, but it doesn't always. So what do you do in that situation? You just run away and cry. I'm just kidding. No, I think, so what I really try to think of is like, so on activity result, I think of that as using that as just like getting a piece of data back. So your experience is that resume was called before on activity result? Is that what you're saying? Well, let me ask you, what did you do in that situation? So you had to use flags and repeat the logic of both methods. So that's exactly what I would do. I would try to figure out, first I would figure out, is my understanding incorrect? Then I would, say if my understanding is correct, then I should probably figure out how to get the documentation fixed. But ultimately, when, rubber meets the road and I have a client app that has to be delivered, I will try to find a workaround. And how do I do that? I reach out to people like you, right, in the community who have done this before and can help me. Anybody else? Okay. Well, thank you so much for hanging out with me. I really enjoyed this.